Alright, this is the last lesson in Chapter 10. We're talking about segment relationships in circles. Remember, segment is just a line with two endpoints. We're going to skip all the way down to some definitions. The first one is segments of a chord. Okay, so when two chords intersect in a circle, each chord is divided into two segments. Okay. In other words, if you have a circle, in other words, in a drawing, okay, and let's say you have two chords, one here and another here. Okay, it is divided into two. Okay, we have this half, and obviously on the red, this half and this half. Okay. The rest of these definitions is going to be a drawing. Okay. The tangent segment, if I have a circle, let's do one big drawing here. Okay. And I have an angle outside my circle. And it's going to go there. This angle is going to stop here. The tangent segment is right here. Right, we talked about tangents of the circle. It's where it intersects just at one point on that circle. That's my tangent segment. We also talked about secants. Secants are lines going through my circle. This right here is my secant segment. Right, a secant goes through my circle. So that's how I remember secant is inside. And then my external my external segment is right here. We have a couple new formulas today, so formulas are getting to be at large. Segments of chords. When you have chords that intersect inside a circle, we can find their lengths. And look at our theorem. EA times EB. So you stick to one segment. EA times EB is always equal to EC times ED. Okay, so stick with one segment, multiply those two together. This segment, the one segment, right, that's being intersected, multiply it together and set it equal to the other segment being multiplied together. There's our drawing that I just drew. Let's go here. We have an angle, an exterior angle like we have here in E. Okay, we're just talking about the segments. We're not going to be talking about the angles. The length from E to A, times the length of E to B, so we're always starting at E, is equal to the length of EC times the length of ED. Okay, so we multiply. We always start with our angle. We always start at our angle, or our vertex, however you want to say it. Look at the difference between these two drawings. Notice we have a secant segment here in both, okay? And in this next one, we only have one secant, and we actually have a tangent segment here, okay? So that's our difference. We have a little bit different formula. Again, we're starting at E. Okay? EA squared. We have to multiply EA twice. Is equal to, and the other is just the same, EC times ED. Before we get on our extra practice, I want to go over here because we had a couple examples that we skipped over. Okay, this one right here. This is where we have two segments in a circle. We multiply 1/2 by the other, and we don't know what this is. We want to find that. We're going to call that x. So 18 times x is equal to the other half, 9 times 8. So 18x is equal to 72. And 18 divided by 72 is it 4? I'll just grab my calculator quick. Sorry, 72 divided by 18 is 4. Okay, so when you're going to final answer, you get x equals 4. Alright. Was there any other examples? Nope. Okay, so we're going to come back to 1. We're going to start with 2. So it's the exact same thing we just did up above. Take one segment, 10 times 7x. 10 times 7x. That is equal to 15 times 5x minus 2. Okay. Notice how I use parentheses. It's because it's 15 times this entire length, and this entire length is 5x minus 2, not just 5x. Alright, we need to use parentheses there. So on the left side of my equation, 10 times 7x is 70x. On the right side, I have to distribute. Okay, 5 times 15, or 15 times 5x is 75x. 15 times negative 2 is negative 30. To solve this equation, I'm going to subtract 70x, both sides. So I get 0 is equal to 5x minus 30. I'm going to add 30. So 30 is equal to 5x divided by 5. X is equal to 6. Okay. Now I want to go back to number 1. The reason I skipped it is because it's a little more difficult. I don't know why they make the difficult problem in number 1, but they did. Start with our whole numbers. 6 times 5 is going to be equal to x, and then we have to put in parentheses x plus 1. On the left side, 6 times 5, that's easy, that's 30. We know our multiplication. On the right side, we have to distribute this x. So it's x squared plus x. right? X times x is not 2x, it is x squared. Okay. Now, this is where a ton of students struggle. They don't know how to solve for x. What we have to do when we have x squared and an x is we're going to subtract 30 from both sides. So I'm going to bring this off to the right side. We have 0 is equal to x squared plus x minus 30. Okay. This is where people get confused. Right now, we have to factor. You have to factor out a trinomial, x squared plus x minus 30. To factor out a trinomial, it's basically like reverse foiling. Okay, we are going to have two sets of parentheses. Okay, the first things being x and x, because we get x squared, right? We need to get x squared. So first things are x times x. The other two spaces have to deal with 30. 30, okay? What I'm going to do, I want you to find the factors of 30. I know it's 1 times 30. I know it's 2 times 15. I know it's 3 times 10. And I know it's 5 times 6. And ask yourself, this is where it gets confusing, which of those added together, which of these factors added together get us x, or 1? 1. Which of these gets us 1? Our answer is 5 and 6. Okay, so we're going to put 5 here, 6 here. Doesn't matter where they go. It could be 6 and 5, just flipped. And we have a positive 1x. So when we add 5 and 6 together, or subtract, how do we get a positive 1? We need a positive 6 and a negative 5. Again, this is still equal to 0. Now, how do I solve for x? Still might be asking. I don't get it. How do I solve for x still? Break up each one. Start with x minus 5. Set it equal to 0. Okay? X minus 5 is equal to 0. You can do this. You can solve this algebraically. Add 5 to both sides. X equals 5. There's an answer. Okay? Do the same thing with x plus 6. X plus 6 equals 0. Subtract 6. X equals negative 6. Okay? So, possibly two answers for x. However, in this chapter, we're only going to use one answer. We're only going to use the positive number. So x was a positive and a negative. It was 5 and negative 6. Our overall answer for number 1, our final answer, is just 5. Okay? Not 6, just 5. If you have questions on this, please ask me. I know a lot of kids get confused on this. Okay, we're going to skip 3 right now. We'll come back to it. We're going to go to 4. Go to 4. Okay? This is our tangent segment, x plus 1. And remember, when we have a tangent, we have to square it. So on the right side, or with x plus 1, we're going to x plus 1 squared. Actually, I need to bring this down. We're going to write everything down here. Okay? This is equal to x minus 1. That's our first part. times x minus 1 plus 5. Now, on the left side, x plus 1 squared. We talked about this in this chapter. We have to write x plus 1 twice. We get x plus 1 times x plus 1. And we're going to have to FOIL that out. This is equal to, I'm just going to simplify right now. X minus 1 times x plus 4. Next, we have to FOIL. X squared plus x plus x plus 1, that's everything multiplied together, is equal to, FOIL this as well, x squared plus 4x minus x minus 4. Okay. Now, this is going to get messy quick. Should I bring everything up? Oh, that was nice. Okay. Alright, now let's simplify. We get, on the left side, x squared plus 2x plus 1, right? X plus x is 2x. That is equal to x squared. 4x minus x is 3x minus 4. Now, we can start adding and subtracting to both sides, because we've simplified everything on both left and right. I'm going to subtract x squared. Okay, that'll go away on both sides. So we're done with x squared, which is nice. I'm going to subtract 2x. Okay, so I'll get rid of it here. And then I'm going to add 4. We'll get rid of it here. So on the right side, 3x minus 2x is x. On the left side, 1 plus 4, or 4 plus 1 is 5. Done. Okay, so it actually works out pretty nice there at the end. It's a long process, but it worked out. We have one more problem too. Okay. I'm going to start with this. 2, left side. Actually, let's scroll down and make even more. That might be even better. Okay. Start again. 2 times all of this, which is 2 plus x plus 3. Okay? That is equal to x plus 2 in parentheses times all of this, which is x plus 2 plus 1. Now, just like the last problem, FOIL, or distribute, sorry. We get 4. Actually, you know what? You can do this one of two different ways. You can either simplify right now inside the parentheses, or FOIL it out. It does not, or distribute it out. It doesn't really matter. I'm just going to distribute. So 4 plus 2x plus 6. That's equal to x squared squared plus 2x plus x plus 2x plus 4 plus 2. Now, when I simplify on both sides, I get 2x plus 10 plus 4 plus 6 make 10. On the right side, I'm going to look at all my like terms right here. 2x plus x plus 2x, that's 5x. So I'm going to get x squared plus 5x plus 6. Alright. Now that I've simplified on both sides, I'm going to subtract everything over to one side. Get everything all by itself. So I'm going to subtract 2x, and I'm going to subtract 10 to get rid of everything over here. Minus 2x is minus 10. Now I'm going to bring this problem out to the right. I'm going to get 0 is equal to x squared plus 3x minus 4. And just like the problem in number 1. We're going to have two sets of parentheses. We're going to have x, we're going to have x. The last two numbers are all based off this last number. Factors of 4 are 1 times 4 and 2 times 2. And we're asking ourselves which one gets us to a 3. More specifically, a positive 3. But how can we add and subtract these factors to get 3? And it's going to be a 4 and a 1. Okay, so 1 and 4. We need a positive 3, so we need a positive 4 minus 1. That's equal to 0. And now to solve, just break these up into 2. X minus 1 is equal to 0. So x is equal to 1. X plus 4 equals 0. We're going to subtract 4 and get negative 4. Again, for these answers, we're only sticking with the positives. So 1 is our final answer. Hey, if you have any questions, please reach out. Please ask me, email me, ask me in class, or me, whatever you need.